Hello friends, I am Professor D.G. Trivedi going to take your fourth lecture related with the electrodynamics. This is the 5.12 topic of chapter number 5 of electromagnetics be below. Related with this one is nothing but electromagnetic energy and momentum. So electromagnetic field which is having energy and that total energy we will find out here, that is known as the electromagnetic field energy, and the field also contains the momentum. That's why we are going to find out the electromagnetic field energy and electromagnetic field momentum here. The expression for that we are going to derive over here. We have already studied earlier that if there is a static electrostatic field is there and static magnetic field is there, that means it is independent of the time, it is a function of r only, then the magnetic field energy and electric field energy can be given by this expression. W is equal to 1 half volume integration of E dot d d tau. This is the electrostatic energy inside the electric field or static electric field, and Wm is the magnetostatic energy in the magnetic field or static magnetic field independent of time. 1 half volume integration of B dot H theta. So equation 5.84 represents the electrostatic field energy as well as magnetostatic field energies are there. Now we are interested to find out what is the electromagnetic energy is there. Electromagnetic energy means if there exists electric field and magnetic field, both the fields together simultaneously, and moreover they are time dependent. That means their time varying fields are going to be there. That means the electric and magnetic field is a function of position vector r as well as the time coordinates t also. And then what is the expression for the total electromagnetic field energy that we are going to develop here. So we are starting with the force exerting on a charge q. If there is a charge q is there which is moving an electromagnetic field, that means electric field is also exerting a force on the charge q and magnetic field is also exerting a force on a charge q, but moving charge will be exerted force by magnetic field. This equation was given by Mr. Lawrence, and this is a well-known equation. You know very well that F is equal to Q into electric force, that is QE, and magnetic field force is equal to Q into V cross V will be there. That is going to be combined. So Q into E plus V cross V will be there. Now, if we consider that this charge is experience force because the electromagnetic field, then what is the rate at which work is done? The rate at which work is done is called the power. That means work per unit time. That means what is the expression for work? Force dot displacement vector upon time. So d upon t, the displacement upon time is nothing but the velocity. So we can write down this expression as the rate at which work is done on this charge is equal to F dot V is equal to Q into E plus V cross V dot V. Remember, all bold letter represents that it is a vector quantity. So here the first term E into Q into E dot V will be there. Second term V cross B dot V will be there. But because V cross B is perpendicular to the magnetic field vector and dot product of the two perpendicular vector, that means V cross B and V vector, they are perpendicular to each other. So the magnetic field does no work on this charge q which is moving perpendicular to the magnetic field, and hence the magnetic force is going to be 0. So this expression is going to be 0. That means F dot V is equal to Q into E dot V will be there. This indicates the rate at which work is done on the charge q which is moving with the velocity V. And electromagnetic fields, the magnetic field does no work as it is perpendicular to the velocity of the charge. There exists a continuous distribution of this charge. Now we'll consider that instead of single charge q, if inside some volume, this charge Q is distributed continuously and non-uniformly. So this charge Q is equal to the volume integration of rho d tau will be there. So we can replace in that previous expression that Q is going to be replaced by volume integration of rho into E dot V d tau. Now rho is the volume charge density multiplied by velocity, and that will give you the current charge density, the charge which is going to be moving per unit time through cross-sectional area, that is called the unit current charge density will be the current density will be there. So rho into V is represented by the current density J. So this expression is nothing but the volume integration of E dot J d tau. Always remember now this equation, volume integration of E dot J d tau, what it indicates? The rate at which work is done on the charge distribution inside the volume by field forces, that means electromagnetic forces, is given by this equation 5.87. Now we can substitute the value of current density J from the Maxwell's equation. Maxwell's third equation, curl of H is equal to J plus del D upon del T. So making the subject of the formula J, we can say that J is equal to curl of H minus del D upon del T. So in this expression, the volume integration of E dot J d tau, that is equal to the volume integration of E dot curl of H minus del D upon del T d tau. So we have substituted value of J in terms of curl of H minus del D upon del T. That is equation 5.88 will be there. Now we can separate this two separately. That is going to be E dot curl of H, that is going to be first term, and the second term E dot minus E dot del D upon del T, that is going to be second term will be there. So that way we can separate this two term. E can be operate on both this one. Now first term E dot curl of H, that can be converted into two different terms by using this vector identity, that is divergence of H cross E, that is equal to H dot, that is H dot curl of E minus E dot curl of H will be there. So making this formula subject of the formula, because that is we have, so E dot curl of H is equal to divergence of H cross E plus H dot curl of E, that we can substitute here in place of this formula. So this is equal to divergence of H cross E, and what is the second things? Curl of AE is equal to minus del B upon del T, that is again the third law of the Maxwell's equations, that is curl of E is equal to minus del B upon del T, that can be substituted. So this is replaced by minus H dot del B upon del T by equation 3 of Maxwell's equations. So this entire term E dot del cross H can be replaced by this term curl of, sorry, divergence of H cross E minus H dot del B upon del T can be replaced for this terms. Therefore, E dot J d tau, volume integration of E dot J d tau, that is equal to the volume integration of divergence of H cross E, that is the first term. Second term, from here we can write E dot minus E dot del D upon del T, and the third term from here minus H dot del B upon del T d tau. This we have written in symmetrical way. That means E and D is nothing but the electric field, H and B is nothing but the magnetic field. So we now separate these two integrands. The first integrands is going to be like this, volume integration of divergence of H cross E d tau. Second integration, minus sign is going to be common, taken outside, the volume integration of E dot del D upon del T plus H dot del B upon del T d tau 5.89. So this way we have obtained the equation 5.89. Now the first integral is divergence of h cross e d tau is there. So we can utilize the divergence theorem and we can convert this volume integration into the surface integration. So using the divergence theorem, we can transform the first term into the surface integration. That means the surface volume integration of E dot j d tau, that is equal to, the first term was this. So we can write the surface integration of h cross E dot unit vector En caret and surface element ds will be there. So this is the area vector, localized area vector everywhere on the surface which is surrounding that volume, minus, this is still volume integrations of E dot del D upon del T plus H dot del V upon del T d tau. So we can write down this equation in this forms. Now we'll make this terms a subject of the formula. So this will be the subject of the formula and this will be taken this side. When this will be taken on this side, that means this becomes negative. And we know that A cross B is equal to B cross H. B cross A. So similarly, H cross E is equal to E minus E cross H. So that way it becomes positive when interchanging the E and H in order, where S is the surface boundary of the volume V. Therefore, we can write a minus volume integration of E dot del D upon del T plus H dot del B upon del T d tau. So we have made this is as a subject of the formula, that is equal to the first term, the rate at which work is done by the field forces on a charge within the volume, that is E dot j d tau plus surface integration of E cross H, because interchanging this one again it becomes positive. So E cross H dot unit vector En caret the surface element ds, that is equation 5.90. Now we'll simplify this one on the left hand side. That is, if we consider mu and epsilon are constant, because d is equal to epsilon e and b is equal to mu h. So if we consider that d and mu and epsilon are constant or particular linear media, they are supposed to be constant everywhere, and hence this equations can be written as volume integration of E dot del D upon del T plus H dot del B upon del T d tau, that is equal to differentiation of total differentiation of del T of 1 half E dot D plus B dot L is there. You can consider here also D is equal to epsilon E. So E dot E is equal to E square, magnitude of E square. So 2 times E and del E upon del T is there, multiplied by mu. So that is going to be del D upon del T. Again you will get this equation. Similarly, for B is equal to mu H, you can substitute here and you will find out the second term. So this term can be represented in the form of this terms. So left hand side we can write down minus sign is there, differentiation del T. That means time rate of change of this thing, this quantity within the integration. Volume integration of 1 half E dot D plus B dot H d tau, that is equal to E dot J d tau plus the surface integration of E cross H dot unit vector En caret ds will be there, 5.91. This equation represents the law of conservation of energy, and we have to interpret each and every term of this equation 5.91. What is the left hand side? You can see that volume integration of 1 half E dot D plus B dot H d tau. Now, if you see that initially we have seen that for electrostatic, if there is an electric field is going to be exist, the energy within that electric field is given by 1 half volume integration of E dot D d tau, and magnetic energy is given by Wm is equal to volume integration of 1 half B dot H d tau. So in electromagnetic field energy, there is a electric field energy also as well as magnetic field energy also. So we can say that this expression is nothing but the representing total electromagnetic energy. So volume integration of 1 half E dot D plus B dot H d tau is nothing but the total electromagnetic energy because of electric and magnetic field. And this minus d dt represents that total electromagnetic energy decreases per unit time. That means the time rate of change of the electromagnetic energy in a electromagnetic field decreases in a volume every second or per unit time is representing a physical interpretation of left hand side. What is the right hand side? The first term is already defined, that is the work done by the field forces on the charge and moving charge within the volume, which is a charge distribution, is contained. And this is nothing but the flux E cross H, which is nothing but it is having a dimension of energy per unit area per unit time. That means energy coming out through unit area of the cross section per second. That means it is some kind of flux. So this represents total flux coming out through the boundary of volume V, and that is called electromagnetic flux coming out through the boundary per unit time. Since the electromagnetic field consists of electric and magnetic fields, it is reasonable to assume that the sum of the energies given in equation 5.84 represents the total electromagnetic energy. So this 1 half E dot D is electrostatic energy, 1 half E dot B dot H d tau is the magnetostatic energy. So summation of this will give you total electromagnetic energy dense field. So this is the volume integration of something d tau. That means 1 half E dot D plus B dot D is nothing but electromagnetic energy density, energy per unit volume, just like charge per unit volume, rho. Here energy per unit volume in a electromagnetic field within that volume. So since the electromagnetic fields consist of electric and magnetic fields, it is reasonable to assume that the sum of the energy given in the equation 5.84 represents the total electromagnetic energy. Hence, we may take Em is equal to 1 half E dot D plus B dot H as electromagnetic energy density. We may therefore interpret the left hand side of the equation 5.91 as the rate at which the energy stored in the electromagnetic field diminishes or it is decreasing. Minus d dt represents the amounts of some quantity decreases per unit time. So the amount of electromagnetic energy decreases stored in a volume every second. That is nothing but the left hand side. Now right hand side, the first term on the right hand side gives as stated above the work done by field forces on a charge contained in the volume per unit time, because it is time rate of the work done. The vector E cross H has the dimension of energy per unit area per unit time, and hence the last term may be interpreted as representing the flux coming out. Energy that flows out of the boundary per unit time. Flux here it is in terms of energy. So energy that flows out of the boundary per unit time. The vector E cross H, which gives the rate at which the energy flows across the unit area of the boundary, is called the Poynting vector. So now E cross H, which is having a dimension of energy plus coming out through unit area of the cross section every second. So it is energy flux, and we now designate it is a Poynting vector n. So n is equal to E cross H. So energy that flows out of the boundary per unit time, the vector E cross H, which gives the rate at which the energy flows across unit area of the boundary, is called the Poynting vector and is represented by the symbol vector n. The equation 5.91 may also be written in a differential form as. So this equation 5.91, this is in integral form. We can convert into the differential form. How we can convert into the differential form? This is your surface integration. This is to our volume integration. So let us convert again this surface integration into the volume integration using divergence theorem. So divergence of E cross H, and E cross H is nothing but n. So we can write here, this is nothing but the volume integration of divergence of n deta will be there. So everywhere there is a volume integration, we can remove that volume integration. That means minus del T of, this is nothing but electromagnetic energy density. So we can write minus del T of Em, that is equal to E dot J plus divergence of n will be there. So this equation is converted into differential forms. Now this term we can take this side. So E dot J, that is equal to minus E dot J, that is equal to dm upon dt plus divergence of n. Now J is equal to sigma E. Sigma is the conductivity of the medium. And if the medium is having a zero conductivity, that means medium is non-conductor, then we can write that J is equal to 0. So in that case, we can write minus E dot J is equal to 0. That means we are having this term del dEm upon dt plus divergence of n is equal to 0, and this is nothing but the same form of equation of continuity, that is divergence of J plus del rho upon del T, that is equal to 0, or that is nothing but the charge conservation law, you can say that. So this equation has exactly the same form as the equation of continuity, equation 5.50. The volume density of the conserved quantity here is Em. We can write here like this way also, divergence of n is equal to minus del Em upon dt. So rho is going to be replaced by Em. So the conserved quantity, instead of charge density rho, here volume charge density rho, here it is the volume energy density, electromagnetic energy density, Em is going to be conserved quantity, and current density J is replaced by the here the energy flux, that is N, which is nothing but E cross H. This equation has exactly the same form as the equation of continuity in equation 5.50. The volume density of the conserved quantity here is Em and the current density is N. This analogous leads to the same conclusions as above regarding the identification of the flux of electromagnetic energy with the Poynting vector E is equal to N is equal to E cross H. Thus, equation 5.91 represents the law of conservation of energy. Remember, this is a statement of Poynting theorem. Equation 5.91 represents the law of conservation of the energy. It states that the decrease of the electromagnetic energy, per unit time dm upon dt minus sign is equal to, in certain volume V, is equal to work done by the field forces per unit time plus the flux flows outwards per unit time. This is known as the Poynting theorem. So you can read this equation like this one. This is the equation 5.91, mathematical representation of Poynting theorem. That is, time del minus del dt means the time rate at which some quantity is decreasing. That means the electromagnetic energy in a volume V decreases per unit time. Where that unit is going to be, energy is going to be converted, the part of the energy is going to be utilized for work done on field forces, work done by the field forces on a charge distribution inside the volume every second or per time unit time plus energy that flows out of the boundary per unit time. So part of the energy is utilized to work done. That means charge is supposed to be moving inside that one. And for that, part of the energy is going to be utilized to work done. And part of the energy is coming out of the boundary or out of the surface per unit time. This way, this equation 5.91 is a representation of energy conservation law. And it is known as the Poynting theorem. So conservation of the energy, and this is known as the Poynting theorem. Remember, again I am repeating this one. This is a statement for the Poynting theorem. It can be asked as a single questions. 5.91 represents the law of conservation of energy. It states that the decrease of the electromagnetic energy per unit time in a certain volume V is equal to work done by the field forces per unit time plus the flux flow outward per unit time. This is known as a Poynting theorem. This is related with the electromagnetic energy. Now we are going to touch the second topic of this topic, and that is electromagnetic momentum. Similar computation shows that electromagnetic field possess a momentum. Electromagnetic field also have a momentum, and that is called electromagnetic momentum, which is not having mass. That's why it is called the momentum, field momentum. So to start the field momentum, again we are going to start with the force exerting on the charge inside a continuous distribution of charge in a volume. So Q is equal to rho into d tau we are going to consider here. So the Lorentz force exerting on a charge Q which is moving in electric and magnetic field B is given by normally F is equal to Q into E plus V cross B. So here this Q is going to be replaced by the volume integration of rho into d tau. So rho into E d tau, that is electric force is going to be exerting on the charge density rho plus rho into V, that is rho into velocity, that is nothing but the current density J. So it is replaced by J cross B d tau, magnetomotive force will be there. So that way this is nothing but the representation of the force exerting on a region containing both the charge and currents. That means the force exerting on a charge and currents due to the field forces. So force on a region containing both charges and current is given by F is equal to the volume integration of rho into E plus J cross B d tau. This is equation 5.94. Now we know that Newton's second law of the motion, F is equal to dp by dt. Time rate of change of momentum is nothing but the force. So force can be replaced by this expression dp mechanical upon dt. dp mechanical upon dt is nothing but the momentum. So rate of change of the momentum is equal to force. So P mechanical is the sum of the momenta of all the charged particles. That is equal to the volume integration of rho into E plus J cross B d tau. So equation 5.94 is represented as 5.95. Now using the Maxwell's equation, we can replace rho, the charge density, volume charge density rho is equal to divergence of D, that is the first equation Maxwell's, and J is replaced by curl of H minus del D upon del T, third Maxwell's equation. So we are substituting in this equation the volume charge density rho as well as the current charge density, current density J is going to be replaced by this expression. Therefore, dp mechanical upon dt, that is equal to the volume integration of divergence of d into E, divergence of d into E plus J is equal to curl of H minus del D upon del T cross B d tau will be there. So equation 5.96 is going to be converted into this forms. We can separate these things. That is equal to the volume integration of divergence of d into E, the first term as it is. A cross B is equal to B cross A. So we are taking B first now. So B cross del D upon del T, because this 9 minus sign is going to be cancelled out and it becomes positive. So plus B cross del D upon del T, and this when we are taking here front, so it becomes minus. So minus B cross H d tau will be there. Now let us evaluate these things. Del T of D cross V. D is the displacement electric field vector and magnetic field vector B will be there. So if we utilize the product rule, that means del T of D cross B is equal to taking the first term constant D and taking the differentiation of the second term cross del B upon del T plus differentiation of the first term del D upon del T cross B. Now we are having B cross del D upon del T. So we'll make the subject of the formula this one. So this will go into the left hand side. It becomes negative. Again interchanging their orders. That means B cross del D upon del T, it becomes positive. That is equal to D cross del B upon del T minus del T of D cross B will be there. That can be substituted for this part. So dP mechanical upon dt, that is equal to the volume integration of divergence of d into E, that first term as it is. For this one, we are putting this one plus d cross del B upon del T minus this term del T of d cross B minus B cross curl of H d tau will be there. Now divergence of B is equal to 0. So addition of divergence of B into E to the square bracket does not alter the result, because we want to make a symmetry divergence of D into E plus divergence of B into H. So to make a symmetry we are adding this term, because divergence of B is equal to 0, divergence of B into H is also going to be 0. It makes no difference to the result. So we are adding here. So divergence of D into E plus divergence of B into H will be there, and del B upon del T is nothing but your from the Maxwell's third equations, that is curl of H is equal to minus del B upon del T. So we can substitute here for that one. So what happens this one? This is equal to minus D cross curl of H will be substituted here. That is going to be making the symmetry with this one. Minus B cross curl of H will be there. Here minus D cross curl of E will be there. That is going to be symmetry. This term can be taken on the left hand side, and left hand side there are two terms will be there. Therefore dP mechanical upon dt, and the second term plus d dt of volume integration of d cross B d tau, that is equal to the volume integration of V divergence of D into E plus divergence of B into H. So there is a symmetry for the electric field as well as mechanical field in a dot product terms. Plus minus, and this last two terms was taken inside the bracket, so minus sign was taken outside. D cross curl of E plus B cross curl of H d tau will be there. That way, because we have substituted, curl of E is equal to minus dB by dt. So you can see that on the left hand side there are two time rate of change of this time rate of change of the momentum. So this should be also momentum. This is the momentum of the particles. That is, particle which is having a mass with that momentum is called the P mechanical momentum. Time rate of change of the mechanical momentum, time rate of change of the electromagnetic momentum, which is nothing but the field momentum, we can say that, because they don't contain mass. Clearly the integral in the second term of the left hand side represents the momentum. So this is also representing the momentum, time rate of change of the momentum, and that momentum we designated here electromagnetic momentum. So the integral in the second term of the left hand side represents the momentum. Since it does not associate with the mass of the particle and consists only of the fields. We identified it as electromagnetic momentum P field. Instead of P mechanical, it is a P field. This is the momentum of the particle which is having a mass, electron and protons which is having a mass. But this is because of that, the field which is going to be generated, that field momentum is represented by P field. The vector G, this D cross B is designated as another vector G, which is called momentum density vector G. The vector G is equal to D cross B is called electromagnetic momentum density. The right hand side can be converted into the surface integral and identified as a momentum flow. So on the right hand side, this one, this can be converted into the surface integration, and that means something which is going to be coming out of the surface of the volume V, and that is going to be the momentum flow. Momentum which is coming out through this surface is called the momentum flow. So right hand side can be converted into the surface integral and identified as a momentum flow. We conclude from the equation 5.96 that total moment of the closed system consisting of the field and particle momentum is going to be conserved. So left hand side, it is nothing but the summation of the particle momentum plus the field momentum, and this summation is going to be conserved quantity that we can prove it. It may be noted that momentum density vector G is related with the Poynting vector N. So G is equal to D cross V, D is equal to epsilon E, and B is equal to mu H. So we can substitute for D and B in terms of the electric and magnetic field. So epsilon E plus mu H, and mu epsilon are taken outside. So E cross H, and E cross H is nothing but the Poynting vector N. So we can relate that momentum, electromagnetic momentum density G is related with the Poynting vector N. Mu epsilon N will be there. That is equation 5.97. So this way, in this topic we have studied about the electromagnetic energy also, and electromagnetic field also contains the momentum. That two topics we have studied in this particular chapter, and this way we are completing this chapter 5. Next time we are starting with the next chapter, electromagnetic waves will be there. Thank you very much, friends.